Beyond the faint light of our sun, a very mysterious world is hidden. Beyond the last planet of our solar system, and even farther than the mysterious world of the Oort cloud, in this infinite and mystery-filled dark space, there exists such a place. It is a place we have always dreamed of reaching. But perhaps reaching there is still a great challenge for human civilization. Alpha Centauri is our closest star system. A shining light that inspires hope in the night sky that perhaps we are not alone in this universe. There is a hope about our home, wondering what if one day Earth is no longer habitable. This star system is our new home. If we ever manage to cross this vast distance, what will we find there? A new world or another disappointment that will remind us how small we are in front of the universe? Get ready for an astonishing journey to Alpha Centauri, because here we are going to unravel many mysteries of Alpha Centauri. This journey will be amazing, will seem impossible, and will confront us with a truth that might force us to think about our universe and our own existence. The stars do call us, but at the same time, they also warn us that the path to them is surrounded by darkness. Alpha Centauri is only of mystery. It's not a star, but a system that's full of complexities and wonders. It has three major celestial bodies: Alpha Centauri, a star that's just like our sun, and it's officially known as Rigil Kentaurus. The second star of this system is Alpha Centauri b, also known as Toliman, and the last one is the mysterious Alpha Centauri c, which is also called Proxima Centauri. It's a red dwarf that orbits around these two at a distance of 0.2 light years, a lone wandering star that is right at the edge of its stellar family. Proxima Centauri has a secret, a planet called Proxima b. It was discovered in 2016. This rocky exoplanet is very close to its star, just 0.049 astronomical units away. But still, it is in the habitable zone of Proxima Centauri. So, could this be the second home for our human civilization? Does it have intelligent life? Or are there conditions here that will forever keep this planet shrouded in mystery? Proxima b is our closest known exoplanet. It's only 4.246 light years away. In cosmic terms, that seems really close, but being this close still means a distance of 40 trillion kilometers. It's such a huge distance that even light, which is the fastest thing in the universe, would also. It takes 4.3 years to cover this distance. For humans like us, who are here in this universe for just a few moments. For those of us bound to our slow spaceships, this challenge becomes even greater for us. Reaching Proxima b is not just a journey, it's like making a bet with the impossible. So why do we dream of Proxima b? Maybe because it's a mystery waiting to be solved. A piece of the puzzle that fits perfectly into the grand narrative of our existence. But before we set foot on this unknown land, we have to face a harsh reality. A reality that asks us questions we might be afraid to face. The abyss between stars? Just think about it. The distance to Proxima Centauri is 266,000 times greater than the distance between Earth and the Sun. It's about 103 million times greater than the distance between the Earth and the Moon. Voyager 1, which is humanity's fastest interstellar spacecraft, would take 75,000 years to reach there. In 75,000 years, our civilization might have turned to dust, or we might have long forgotten that we ever launched probes called Voyager. The record-breaking Parker Solar Probe, which travels at a speed of 700,000 kilometers per hour, would also take 6,500 years to complete this trip. These numbers are not just intimidating. They remind us that, in terms of technology, we are still at a very early stage of development. Reaching Alpha Centauri is not a simple challenge. It will be a journey that will demand breaking through and going beyond the limits of physics, engineering, and human imagination. And yet, when we gaze into this infinite universe, a strange question arises. Are we meant to cross it? Or does the universe hold some secrets that perhaps we shouldn't unlock? The barrier of light, a cosmic conspiracy. In 1905, Albert Einstein changed the way we understand our reality with his special theory of relativity. Among the many great mysteries of this theory was a bitter but clear truth. No object that has mass will ever be able to surpass the speed of light. This is not just a suggestion, it's a cosmic rule that cannot be broken. It's embedded forever in the fabric of space-time. When an object accelerates, its energy turns into mass. The faster it moves, the heavier it becomes. Then a point will come when it will need infinite energy to go any faster. Just think. If an astronaut reaches 99.9% of the speed of light, his 80-kilogram mass will increase to almost 2 tons. The closer you get to the cosmic speed limit, the bigger the challenge becomes to increase your speed. Crossing the speed of light is like trying to jump over a wall of infinite height. No force, no power can take you to the other side. Even if we reach the speed of light, the journey to Proxima Centauri would still take about 4 years. But this is just a best-case scenario. A dream that seems almost impossible due to vast energy requirements and the laws of physics. Reaching such speeds is not just a technological challenge. This is a battle against the very nature and principles of reality, one that is impossible for us to win. Death of hope, time dilation, and yet this universe is full of paradoxes. When a spaceship travels close to the speed of light, a strange phenomenon occurs. Time dilation. A spacecraft traveling toward Proxima Centauri at relativistic speed experiences time passing more slowly for its crew. For an observer on the ground, this journey may seem to last for decades or even centuries. But for the travelers inside the spacecraft, it will feel like only a few years. But time dilation is not just a subjective compression. Just imagine a spacecraft that reaches 95% of the speed of light. For an observer on Earth, the distance to Proxima Centauri, which is 4.24 light years, would take about 4.47 years to reach. But for the crew, due to time dilation, this journey would feel like only 1.39 years. The faster the spacecraft travels, the smaller this difference becomes. But if the spacecraft travels at 99.9% the speed of light, then for the crew, a 1-year journey would feel like only 2 weeks. And if the speed reaches 99.9999% of the speed of light, then a journey that would take thousands of light years would be over for the crew in just a few decades or even sooner. This phenomenon raises a profound question. Can relativistic travel open the path to interstellar exploration? Maybe, but time dilation is not a miracle. The energy required to reach such speeds is also unimaginable. And there are dangers too, such as collisions with high-energy particles, lethal radiation, and destructive interactions with interstellar matter. These challenges are still immense. At such speeds, even a thin layer of interstellar gas would turn into deadly plasma. For both the spacecraft and its crew, empty space, which once seemed like a calm and completely empty area, would turn into an invisible battleground. A battlefield where no spacecraft has survived so far. Time dilation does promise to take us to distant stars, but it also brings with it deep and mysterious barriers. Limitations of time dilation, as we saw earlier, require practically infinite energy to take a mass close to the speed of light. So far, we haven't found any propulsion system that can make this possible. And even if somehow the problem of energy is solved, a spaceship traveling close to the speed of light would still find space to be a very dangerous place. Space isn't empty, it's actually filled with countless wandering atoms. Sometimes these atoms gather in complex forms like gas and dust clouds, galaxies, stars, and planets. And sometimes they drift alone as single atoms in this infinite universe between two hydrogen atoms in a cubic centimeter of space. The probability of a collision is one thing, but the certainty of an enormous flow of particles hitting the spaceship during its journey is a completely different matter. At low speeds, the particles are harmless, but with acceleration, they rain down in the form of a dangerous shower. Tiles and highly penetrating ionizing radiation can cause severe damage to the spacecraft, and the atmosphere inside the spaceship becomes extremely radioactive for the crew living inside. Particles that travel close to the speed of light acquire so much energy that they become a threat to any form of life. At high speeds, even passing through a very thin nebular cloud can destroy the entire spaceship. Social and temporal disconnection, a lonely future. Even if we overcome all the technical challenges, one possible problem will remain. Time dilation will have a devastating effect on the relationship between the spaceship and the home planet. For the crew aboard a relativistic ship, time will slow down drastically, but on Earth, the clock will keep ticking at its usual pace. What feels like just 11 years for the crew will turn into millions or even billions of years for the people left on Earth. This harsh truth presents us with an existential dilemma. Astronauts who embark on such a journey will have to leave their world, family, friends, and culture behind forever. And when they return, they will. The Earth will have completely changed for them, or perhaps it may not even be habitable anymore. The society they once left behind will have been lost in the sands of time, either transformed into some alien form or completely vanished. The spaceship will no longer be a means of exploration, but will become their own small world, drifting alone in time and space. The effect of such temporal isolation can even be seen in the fictional idea of the United Federation of Planets in Star Trek. The cultural and technological synchronization necessary for trade and cooperation will fall apart. Would a commercial enterprise even have the motivation to send cargo on a journey where there would never be any connection with the sender again? Such a journey would not be a transaction, but rather cargo that has neither an owner nor a destination. According to the rules of Einsteinian relativity, any spaceship embarking on such journeys would actually become a self-sustained world, completely separate from its origin, drifting away from its purpose. So, would this sacrifice even be worth it? This somber conclusion aligns well with Enrico Fermi's famous paradox. If advanced civilizations exist, then why haven't we encountered them yet? Perhaps the answer isn't that they don't exist, but rather lies in the cruel barriers imposed by the laws of this universe. Time dilation presents us with a harsh reality. Even if we overcome these barriers, for the crew of a relativistic spaceship, time on their home planet will continue at its usual pace. Generations will pass by. By then, everything would have completely changed on their home planet, or perhaps even ceased to exist altogether. So, what would be the purpose of such a journey? A mission to Alpha Centauri isn't just about crossing physical space. It would break the bonds of time and memories that connect us to humanity, that make us human. The Fermi paradox serves as a stark reminder. This conclusion leads us to a poignant, haunting, and profound thought that Enrico Fermi once asked: if advanced civilizations exist, then why haven't we encountered them yet? Perhaps the answer lies in the very limitations we face. The distances between the stars are not just measurements of space. They are like strong fortresses of isolation. These are barriers created by nature itself, barriers that few would even attempt to break. These barriers might confine every civilization to its own celestial backyard, where the dreams of interstellar expansion flicker like a dying flame and eventually fade away. Alpha Centauri, despite being our closest neighbor, remains a dream reserved only for those with immense courage and those willing to sacrifice everything for their world. Does this fact, which highlights the non-existence of visitors, indicate the defeat of all civilizations? Or is it an even deeper warning that, in reality, we are truly alone in this infinite darkness? A new hope, robotic explorers, and light sails. But we know that where humans can't succeed, maybe machines can. The future of interstellar exploration might be in the hands of robotic probes, miniaturized marvels capable of traveling at fractions of the speed of light. Concepts like von Neumann probes, which can self-replicate and colonize, could spread the essence of humanity to the stars. Driven by focused light beams, lightweight probes can be accelerated to up to 20% of the speed of light. And with this, we could reach Alpha Centauri in just 21 years. These solutions are not just part of science fiction, they are very close to our reality. This journey still won't be easy and the obstacles are huge, but humanity has never backed down from doing the impossible. Will these machines one day send us secrets we've never even imagined? Conclusion: the eternal mystery. Alpha Centauri has always been a riddle, a mystery that lies at the edge of human reach. It inspires us to explore new worlds, but at the same time, it reminds us of our limitations. Whether it's in a century, a millennium, or never at all, the dream of Alpha Centauri will always inspire humanity to look up at the sky, to ask questions, and to move forward. After all, the journey to the stars is not just about exploration, it's about facing the vast and unknown universe and trying to find meaning in it. Are we meant to remain strangers here? Or maybe one day we will become one with these stars. Whatever happens, this mystery will remain. Alpha Centauri is our closest star system. You could say that, on a cosmic scale, it's just a few steps away. This binary star system is about 4.376 light years away from us, where even light takes more than 4 years to reach. But Alpha Centauri is our neighbor. It's quite close. We've even reached much farther than this. Star systems and their exo. Have failed to find planets, and the biggest reason for this is that this entire star system, that is, the Alpha Centauri system, is made up of two stars that orbit each other very closely. Because of this, it becomes very difficult to find any planets that might exist around them. Many times we thought there was a planet there, but either there was no planet at all, meaning we got false positive results, or we were never able to confirm those planets. Keeping this in mind, in 2019 Breakthrough Initiatives announced a new project to search for exoplanets in the star systems around us. This project was called the Orbit Locus Astrometric Monitoring of Our Astronomical Neighborhood, or Orbit Locus Astrometric Monitoring of Our Astronomical Neighborhood, which is also the ancient Arabic name for Alpha Centauri. We will find out how this mission will search for exoplanets around Alpha Centauri. In today's video, this mission will be accomplished at a very low cost, and it has been designed by a team from the University of Sydney, and this is its aim. The aim is to search for potentially habitable planets around Alpha Centauri using the astrometry method. In this method, the apparent position of the star is continuously monitored to see if the star is wobbling. If it is, then where is that gravitational force coming from? Like from a companion star or from a planet that is orbiting it? We actually know quite a lot about Alpha Centauri. The primary star of this whole system is just like our Sun. There is a G-type primary star, and the secondary star is an orange dwarf type star, but because of its binary nature, it becomes quite difficult to detect the other possible signals coming from this star system. For example, the transit method used to find exoplanets doesn't work here. In the transit method, astronomers monitor stars for periodic dips in their luminosity. When a planet passes between our telescope and the star, the light coming from the star decreases. With this method, we can discover exoplanets, but here both stars are transiting each other. Here, it becomes quite difficult to understand which luminosity dip is caused by the planet and which one is by the star. The system becomes very complicated here. When two bodies orbit each other, they also affect each other's motion. In this way, we can also discover planets orbiting around stars. This method is called the radial velocity method, and it was because of this that we confirmed the existence of Proxima b planet, which was discovered in the habitable zone of the Proxima Centauri star. After this, 2 more planets were discovered around this star. If we talk about Alpha Centauri, we also got indications of planets there. The first signal was received in 2012 when astronomers talked about a radial velocity signal coming from Alpha Centauri b. That hypothetical planet started being called Alpha Centauri b. But later in 2015, it was revealed that the radial velocity signal was a false positive. Similarly, in 2013, the announcement of a possible planetary transit was made. According to the report, we found out that even if this planet exists, it would be so close to its star that imagining life there is impossible. In 2021, there was also talk about a planet named C1 orbiting Alpha Centauri. This planet was discovered using a new method called direct thermal imaging, but it still hasn't been confirmed to this day. Professor Peter from the Sydney Institute of Astronomy, who is also leading the Toliman project, he says that confirming a planet around these binary stars is a difficult task. They are very close to our home. It will help in exploring, and the Toliman project is one of them. In this, unlike a conventional telescope, the light coming from the star will not be concentrated at a single point. Toliman will use a diffractive pupil mirror pattern, which will transform the light coming from the stars into a very complex flower pattern. This will allow us to take extremely fine measurements of the star's motion, and if there are any indications of an exoplanet, they will be followed up with more powerful telescopes. Its atmosphere, surface chemistry, and even the biosphere's fingerprints there will be followed up. During the mission, telescopes like James Webb will follow up, or the Nancy Grace Roman Space Telescope, which will be launched in 2027. It's the polar target. But before all this, we have to launch the Toliman satellite, and the University of Sydney has contracted with a company called EnduroSat for this. But it has to be launched, and the University of Sydney has one. This is a big hope for us and for Sati as well. It is possible that we might find signs of life in our neighboring solar system and then confirm it through the upcoming mission Breakthrough Starshot. Is about to happen with, but let's see which achievements we can make our own. But all these satellites will have to be launched, and the University of Sydney has there is a solid rocky surface present, unlike other exoplanets, has done with. But all these are located in a solar system made up of different stars. However, they only orbit a single star. Proxima Centauri was launched by Launch and the University of Sydney in collaboration with a company. But it will have to be launched, and due to this special condition, even though Proxima b is so close to its sun, it can still give birth to life within itself. Or you could say that it has already given birth to life, it's just that we humans have yet to see it. Well, in today's documentary, we will take you to the planet Proxima b, where you will land on its surface along with the Sydney company. You will witness the sights of morning, evening, day, and night there, and you will be able to understand the emerging system of life on that planet. So, are you ready to be a part of this amazing journey? If yes, then make sure to fasten your seatbelts, because our journey will pass through many dangers and troubles. But for now, we are at our home, that is, on Earth. From here, first we have to launch the rocket. The University of Outer Space has partnered with a company for this. This boundary is known as the Kármán line. This is the region where the Earth's atmosphere ends, and after this, the harsh and tough weather of space begins. It took us just 3.5 minutes to reach here from Earth. After this, we move towards our next destination, which is called the International Space Station. It is located at an altitude of about 400 kilometers above the Earth's surface. Because now we are literally traveling in outer space, where extreme temperatures can freeze you and, at the same time, burn you as well. But thanks to science, our spacecraft is equipped with all kinds of thermal protection, which is why neither the sun's radiation nor the extreme cold of outer space will affect us much. Wow, we didn't even realize how these 2.5 days just flew by. Now, we are leaving Earth's orbit and will do a flyby near the moon. So get ready for a magnificent view. Wasn't that fun? Anyway, the journey ahead will be very comfortable and peaceful for you, because now we will only open our eyes again when we pass near Mars. That means a wait of a full 8 months. By the way, this is even longer than a bear's hibernation. By the way, this is an imaginary situation where all the planets and the solar system have come into a straight line alignment. Because of this, we are able to see all of them together as we move forward on our journey. And along with that, we are also imagining here that our shortest trajectory to Proxima Centauri also follows a similar straight line pattern. So don't take these things too seriously, just enjoy this simulation and leave everything else to us. So friends, after Mars, then flying by Jupiter, Saturn and Uranus, we have now reached the last planet of the solar system, Neptune. It took us a total of 12 years to reach here. Well, this speed is based on the reference of our existing rockets. But if we use some experimental rockets that are currently in the research stage, then maybe this time could be reduced to 8 years under the same conditions. The rest of the journey ahead is going to take much more time. So now, please sit back and relax in your seats. Because now our journey is going to pass very peacefully. Although we will encounter several asteroids along the way, we will maneuver our spaceship by switching to handle mode. As for the feasibility of reaching Proxima Centauri, for now, it's next to impossible. If we set out on a journey to Proxima Centauri using current technology, it would take us 73,000 years, which is obviously impossible. But if we break the limits of objectivity and let our imagination fly, this time could be reduced to just 4.5 years. Yes, we are talking about the speed of light, about us somehow building a spacecraft that can travel at the speed of light. Irrespective of special relativity and other factors, we can reach Proxima Centauri in at most 5 years. So this is the red dwarf star, Proxima Centauri, around which the Proxima b planet is revolving. Let's quickly see. We enter its orbit and prepare for a smooth landing on it. Well, as the landing sequence begins on the count of 5, we will be on the surface of this planet, so fingers crossed and eyes closed because we are good to go. Friends, we have landed. As we set foot on the surface of this planet, who will be the first person to step onto the surface of Proxima b? Well, our comment box will decide that. Go there quickly and raise the flag of your name. Anyway, the first step has already been taken here. When you look up at the sky, this is what the view looks like. Here, the brightest thing would be this planet's host star, Proxima Centauri, while the other two major stars of this star system also have a bright appearance. That's why. Because of this extremely strange elliptical trajectory, their appearance would be very faint and flickering. Now, since this planet is quite similar to our Earth in terms of size and weight, that's why we would see almost the same geography here. The composition of this planet is mostly like Earth's. According to geomorphological surveys, this planet has mountains, volcanoes, passes, and valleys just like Earth. However, there are some things here that do not match our planet at all, like this planet is tidally locked to its star. Because of this, one side of it always has day and the other side always has night. Actually, its motion is such that one face of this planet always faces its host star. Because of this, energy constantly reaches that region. On the other hand, the dark side always remains in darkness and cold. This really worries us when it comes to the possibilities of life. Because of this special condition on Proxima b, there is an extreme temperature difference, which makes it a bit difficult for life to grow stably here. But even here, there is a middle path. In fact, the area in the middle is the point where it won't be too hot or too cold. In such a situation, life can easily originate there. Now, since this is a simulation and we are optimistic explorers, so according to us, this planet will also have a thick atmosphere with many gases wrapped around Proxima b like a blanket. There will also be dense clouds of water at the lower levels of this atmosphere, which will rain down liquid water. And whenever this water rains down on the surface of Proxima b, it would create a water cycle here again. Our speculation also includes the sight of ponds, flowing rivers, and surging oceans present on Proxima b. However, we also cannot rule out the possibility that deadly solar flares coming from this planet's sun might be causing it a lot of harm. Because it is very close to its star, it is frequently bombarded by solar radiation and destructive solar flares. These likely tear through its atmosphere and enter inside, causing significant harm to any microscopic forms of life that might be developing here. Solar flares that penetrate Proxima b's atmosphere to this extent can destroy the entire life cycle of the planet. But if somehow this planet's extremely dense atmosphere manages to protect itself, then the state of life here would be completely different. There would be liquid water flowing on the surface here, air to breathe in the atmosphere, and we would also witness the evolving life of microorganisms here. We have shown you the sights of this planet through the lens of our imagination. Now it's your turn to embark on this endless journey through space. And friends, if you liked today's video, don't forget to like it and share it with your friends. Also, if you are new to Documentary Library, subscribe and enable the bell notification so you can get videos on astronomy and space science. First of all, friends, see you again with another new informative video. Until then, stay curious, be happy, namaskar,